So I'm very excited to introduce our opening speaker, keynote speaker Mohammed Shakuhi Yekta, and I promise I've actually practiced saying that many times, despite it not coming out. I'll try it again. Mohammed Shakuhi Yekta. He's senior applied scientist at Microsoft and a part-time instructor at Stanford. He previously was a data scientist at Apple from 2015 to 2019. He has a PhD in computer science and has been a keynote speaker at many conferences. We're very fortunate to have him reprise a previous keynote he provided. So we had a last-minute cancellation, but this is so exciting. Deep learning, being clearly the hottest advanced method in machine learning, with so much proven value in image classification, speech recognition. It's such an amazing industrial movement happening around machine learning. I'm sorry, more specifically, deep learning. And it's applied in so many ways. Mohammed himself has experienced working on it with such a wide range of applications. He's the perfect person to kick off with a keynote about this. Indeed, his keynote title is Silicon Valley's Hottest Cross-Sector Applications of Deep Learning. So I'm going to now bring in Mohammed.
Hi, Eric.
Hey, Mohammed. Thanks for joining us.
Thanks for having me.
Okay, so it's my pleasure to introduce Mohammed, and I'll come back in to introduce the next speaker. Take it away.
All right. Thank you, Eric, for the introduction, and you also did a great job pronouncing my name. I know it's challenging. So hi, everyone. Good morning. Hope everyone is doing well. So as Eric mentioned, this is going to be more like a high-level set of applications for deep learning applications. You're going to see like some real industrial applications in the field. Let's start with this code, which soon we're going to be ashamed of telling our kids we used to drive cars and we had to visit doctors to get monitored. I think everyone in this room, in this virtual room, agrees that this is the fact, and this is kind of like the future of the world, and especially like data science and deep learning. Today's talk has like four main outlines. We're going to talk about some data science and deep learning buzzwords, just to explicitly talk about like the difference between traditional machine learning and deep learning concepts. And then we will see some future of IoT projects, and then future of health, and also a real deep learning application in industry, and also a bunch of takeaways there. First of all, I'm going to start with the definition of a data scientist. A data scientist is someone that does data analysis and lives in California. Honestly, that's what a lot of people thought, like especially like a few years back. But a data scientist is someone that is able to use and digest data in a company and an organization in order to solve problems. So problems such as like saving lives, improving healthcare, or like saving money in a business is basically what a data scientist do. The main reason that deep learning is becoming such a hot topic is very simple, because of the amount of data that we're getting in this world. Just to give you like about the amount of data that we're going to see like in the very, very near future, every autonomous car on average generates data equal to 2,600 internet users. So that brings up, the important fact of applications in deep learning and computer vision, because with all of this data, there's a lot of different applications that we can actually use. Since before jumping into IoT applications, I wanted to talk about time series data definition, because all these IoT projects are based on like sensors data. So time series data is any data set which is based on which you have like timestamps on your x-axis, or like a more general description of time series data is continuous data sets. So we have, every data set in the world is either like discrete or continuous. So we call the continuous one time series data. Some applications are like, for example, ECG, electrocardiogram of heart, stock prices, sensors in your Apple Watch or in your like smartphone, in your smartwatch, the accelerometer, gyroscope, and compass sensors are all examples of time series data. This is going to be the takeaway for today about time series data. It's definitely the new big data, and plus combined with deep learning is the next coming wave. And again, you will see some of those applications that I'm talking about in the next few outlines. Talking about like IoT, this is a real example that happened like a few years ago, which a local restaurant wanted to like use sensors data in IoT in order to boost their business. So they used an EMF sensor. They installed an EMF sensor in front of their store, which is, you know, the EMF sensor can actually pick up like electronic devices like cell phones. So in other words, if it's able to like count the number of people crossing by the store, assuming that everyone is like carrying a cell phone. So after they plot the data after like a few months, they noticed there was like a peak in, you know, the number of people crossing by the store, which was around like 10 p.m. And the local business was closing at 7 p.m. So in other words, it was like missing a lot of, you know, potential customers. All they did was expanded their opening hours to like 11 p.m. and the revenue doubled in 1 year. So this is why, you know, sensor data is a gold mine. This one is another project, which I also provided a link here. I will share my slides later, so you can actually go and look into this paper and see this application. I'm going to skip this for now. Another very cool application of, again, deep learning and time series data or like sensors data is making predictions in sensors data. And again, one example is, as you know, like unfortunately, more than 2.2 million people die every year in car accidents. So if we can build an automated system, an intelligent system, which is capable of predicting a car accident ahead of time, that's going to save tons of lives. And there are already some research out there. Again, you can see like two papers here at the bottom. One is like rule discovery in time series that was published in 2015. It's like the the state of the art algorithm for discovering rules in a single dimensional time series data. And the second paper, which was published recently, is a convolutional LSTM model, which is a typical deep learning model used in order to predict a car accident using all the sensors and the cameras inside the car. Even right now that we're speaking, there are a lot of companies like Tesla, which already have this built in their cars, and they claim that they're able to predict a car accident ahead of time. This short video, which you're going to see, is again a dash cam from a Tesla, which is driving in the highway, and you will hear the beep right before the crash happens. There we go. So it is becoming real. It's something real. And again, this is, again, the coolest applications of deep learning. Talking about the future of health, we talked about time series data and time series analysis. ECG, electrocardiogram, is basically one of the main indications of like being able to diagnose heart disease ahead of time. So again, another project our team worked on was to use ECG data in order to predict a heart attack ahead of time. So just imagine, like, on your wearable device, you will get a notification telling you that you're going to get a heart attack next week, and probably you're going to get a heart attack right away. But I mean, honestly, there are some like more intelligent ways to actually handle this. Like, for example, send a notification to your cardiologist, so just to make sure that everything is going smooth and easy. There are a lot of startup companies out there, like Cardia Alloy Core in San Francisco, which already have this portable, cheap sensor device which connects to your smartphone and is able to collect your ECG accurately. Or, for example, even like Apple Series 4 and 5, Apple Watch Series 4 and 5 has this crown sensor, which is again capable of collecting your ECG from your finger. And the accuracy of the sensor and also the predictive model that is being used in the device has the accuracy of like over 98% in order to detect atrial fibrillation ahead of time.
Had I not been wearing...
So the last project that I want to talk about in healthcare is about this very cute and interesting project, again, that our lab worked on during grad school, which is about malaria. So over 1 million people die from malaria every year, and they're mostly children under the age of 5. 90% of malaria cases happen in Africa. Something interesting about malaria is that in general, it's a curable disease. It's not going to kill anyone if it's diagnosed and treated promptly. And so that's the reason that it's killing a lot of people in Africa, because people have access to medical centers in a lot of places, and so they're not able to get diagnosed and also cured. This is a very neat idea, which is actually like a very cheap portable sensor device, like a small box which every box costs around like $3 to $4 only, and is able to detect a malaria, and it's able to classify a malaria from other type of mosquitoes. The whole idea in this device is one single laser sensor, which we put at the entrance of the box. So once the mosquito flies through the sensor and flies into the box, you see like this receiver here at the other side of the laser point, which because of the change of voltage is able to collect these time series data. As you can see, like this yellow and also this greenish time series data is collected from those corresponding mosquitoes. So using this data, we actually trained a machine learning model, which was able to classify a male mosquito from a female mosquito with 99.9% accuracy. So all of this time series data is reflecting many features of the mosquito. For example, the frequency of the wing beats, the size of the wings, the size of the mosquito, the shape of the mosquito, and so on and so forth. So all of that information is again reflected inside the shape of the time series. And building a classification model can actually help identifying the type of the mosquito and also the gender, which is very fascinating. Also, this is a startup company that my former PhD advisor built. It's farmsense.io. You can go to that website and gain more information. This device can also be used in farms to gain information and insight about the mosquitoes that are flying around in that farm. So not only detecting malaria, but also classifying different types and species of mosquitoes is also one of the advantages. So Microsoft is actually working on a drone, which is planning to launch in 2025, so in 5 years from now, that is capable of capturing mosquitoes in the air and detecting and actually sequencing the blood inside the mosquito in order to understand the different type of species that are living in that region, and also to predict an outbreak of disease is also another application. Inside this, so the sequencing of the blood is a very time-consuming process. They're going to be, inside this drone, they're going to be using this laser technology that I mentioned in the previous slide in order to instantly understand and detect the type of the mosquito, the species of the mosquito, and also the gender of the mosquito, and whether it's carrying any disease or not before the blood gets sequenced, because that's a very time-consuming process. It typically takes 12 hours to do this inside the drone. So again, this is a very exciting project that is going to be launched soon. Finally, this is another project done at Stanford. This was, I think, 2 years ago. So they have created and built an application that is called Shazam for mosquitoes. I've provided a link here. You can go and find more details there. So it very similar to Shazam for music. This one is Shazam for mosquitoes. It's able to listen to the flying beats of different mosquitoes, and actually it's able to classify their type and also gender, and again whether it's carrying any disease or not. It's a very cool app. Go ahead and you can go to their website and actually download it for free. And the last topic is a deep learning application in industry. Again, this is a recent project, and I just want to show you some of the challenges and some of these deep learning projects. This is called AOI. It stands for Automatic Optical Inspection. again, this is like a widely used, model and application in industry, and especially in the factories these days. I mean, all of the manufacturers are actually tending to, use this kind of technology so that they can replace it with like manual inspection. So in this project, we wanted to use a deep learning model in order to automatically detect and classify cosmetic defects like scratches, smudges, missing screws, broken connector, and so on and so forth. Um, so we actually came up with a model which initially, like in the first draft, was detecting this large smudge as a snowman, which obviously is like screwed here. But after like training the model and tuning it and actually training on like more and more images, it was able to accurately classify very, very tiny scratches visible on the device, as you can see in this example here, and also able to like classify their type and with like some confidence score, as you can see the number in front of it, which is 0 to 1. So generally speaking, all of these deep learning models that are available out there, especially in the computer vision domain, are like two type. One is object detection models, which means you need to label some objects with like bounding boxes inside the image one by one and determine what class of like defect or like cosmetic defect here it is. Uh, so in these cases, we usually use like some of the state-of-the-art algorithms are YOLO, SSD, semantic segmentation, and so on and so forth. So the base of all of these algorithms are AlexNet neural networks, or like we also call them like CNNs or RNNs, is like the general type. So this is the first type. The second one is actually labeling the images itself. So for example, you have one whole image and you say like, this is a cat, this is a dog. So this is a different way of labeling. And obviously the latter is actually easier to label because it's just like one whole image and you can actually just separate them in like different folders and say this is class 1, this is class 2, and so on and so forth. But for the first one, like YOLO, SSD, and object detection in general, you need to label all the images. So this is like one of the challenges for the first one. But I mean, if you try using YOLO, you will see like how fast and easy it is to use to train and actually test on your classes and on your images. This is the general workflow in any deep learning model and application. First is the labeling part, which I said, it's usually the most like time consuming step and most expensive step because you have to spend a lot of time doing a lot of manual stuff here and label like sometimes like thousands of images manually. The second step is to actually train a deep learning model, whether on CPU or GPU or FPGA. I mean, but like using GPU is like very common these days for computer vision and deep learning algorithms because it's the fastest. And then it's FPGA, and then CPU is like the slowest, which is going to take a lot of time. In this example, the cosmetic example that I mentioned, we wanted to train the model on CPU initially. It was going to take like I think like a few weeks, and then on GPU it only took like 4 hours to train the whole model. And the final step is to test and deploy your model into production. So we have these like 3 steps that you have to go through. And as I said, there's like 2 typical deep learning applications, and especially in computer vision, which you can take advantage in industry. All right, that's all I have for today. Thank you so much for your time. If there's any time left, I mean, I'm open to any questions and answers. Let me know, Eric.
Great, Mohammed. Thank you very much. So actually, while I look to see, we don't usually have time for questions, so I hadn't looked to see about people putting questions here. But if anyone has a question, please type it into the chat. You can see when you go into chat that there's actually a bar between, you can select between session chat and event chat. And if you are on event chat, the speaker or the moderator will probably not see any questions you put there. So make sure that you're on session chat if you have any questions for Mohammed and you'd like to type it. Is there anything you can tell us about the kinds of work that you're doing now that you're at Microsoft?
Of course. I mean, this last project was actually done at Microsoft. So this is like, again, as I said, the kind of like the, the technology, we call it, as I said, AOI, automated optical inspection, is going to be used in the factory line in China in order to replace manual operation. And we've done like a very wide, set of studies. Like we did a bunch of like GRR studies with operators to understand their consistency, how much time it takes for them to actually do like the to be able like to detect these cosmetic defects and so on and so forth. And like this AOI technology is definitely beating the the operators in many cases. It's like it's saving a lot of money. It's like it's very fast. It's very accurate. It's very consistent. So there's a lot of advantages for using this. And again, as I said, like the cost for doing such a project is pretty low because all you have is like one camera sitting up there, and then there's like some and then you have like some machine learning or like deep learning models sitting in there, which are all open source. So YOLO SSD, semantic segmentation that I mentioned, or there are tons of available different like open source implementations for each.
Okay, great. Let me pass one more question to you. Can you speak to how we can make our data lakes intelligent and what that would entail?
So that's a very general question. Like,
Yes.
are they talking about like data lakes in Azure or
Um,
like any databases, for example?
yeah, they didn't specify.
So okay, I mean, okay, so I think combining these, again, machine learning, deep learning algorithms with existing databases and data sets is going to be, I mean, that's the only way that you can add intelligence, right? I mean, just with dealing with like data lake or like any other databases, or like blob storage, whatever that we have in Azure, is not intelligent itself. It's just like some database technology for storing and maintaining your data sets, right? There, but I think like adding these machine learning capabilities on top of those databases is what is going to make that intelligence. And again, especially because Eric was like asking for some other like applications that we're doing at Microsoft. Another topic we're working on is called predictive maintenance in manufacturing. So it means like we're monitoring data, able to like send out some notifications ahead of time before like a tester or like a device goes down. So all of this capability is only is only available if you actually apply machine learning and deep learning on top of your a database storage.
Okay, great. And I'll pass along just one more question to you before we move on to the next session. What are your thoughts on retraining models after time series data disruptions from COVID?
Okay, so I feel like this is 2-3 questions. So they're only talking about like retraining models, or is it only specific about time series models? I'm going to talk about like the more general case, retraining models. So retraining models is usually a very time-consuming step. So that's why there are some concepts in machine learning like called like transfer learning, which you can use whatever you've trained before, and then just add like new data to your model and retrain. It's going to be a lot faster. And again, it's a very, very common method used in deep learning because, as I said, training a model from scratch is going to take you like hours if you want to do it on like thousands of images, and it's going to be very time consuming. Again, the same thing in time series data as well. I think it's the same case. We are able to actually use transfer learning in training, like, for example, convolutional LSTM models in time series data as well. I think that's also available. I mean, you can definitely look into the details, but that's the concept called transfer learning.
Great. Okay, thanks very much.
Of course, my pleasure.
So I really appreciate this. Can you hear the applause? See, everyone's loving it. So thanks so much, Mohammed.